Hello, I'm Toni. I'm holding this presentation in English because I'm not a very good speaker and I want to challenge myself, so take me easy. Okay. As I said, I'm Toni, I'm from Yonder, and I want to discuss with you about optical character. Yeah, the guitar is for show off, but I do play the guitar. Also, let's see what OCR means. So basically, with an OCR algorithm, you can extract the text from an image and turn it into an editable text. So you can put it on your phone and use it as a cheat sheet if you want. So I chose the Zen of Python because I think it's the most inspirational code that I found about Python, and yeah. Let's see where we can use OCR applications. The first one is paperwork. Let's assume that you are an employee for an exchange shop and you have, let's say, hundreds of clients per day. For each client, you need to take his identity card and read all the data there and fill in manually the data in a form, somewhere in an application. So with OCR, you can make this automatically. So you can use your phone, for example, and use an OCR algorithm to extract the text from the identity card and fill in automatically in your forms. So you're going to make a lot of people happy with this. Also in health, let's say that a blind people has a library at home and he don't have books with that type of characters that you can fill with your finger thumbs. So they need to read somehow. So they can use their smartphones to put them over the book and then read the characters and speak it out loud. So they can actually read the text. The next one is translation. Let's say that you're going to China, and there the characters are pretty strange, so you probably don't understand them. There is an application called Google Translate that uses OCR in order to translate the text in real time. So you put your phone with the camera on, and then the text from the image is going to be replaced with the text in your own language. So if you have that application, you can try it. It works.
Magic.
Yeah. So, how does OCR work? Let's assume that we are living in a simple world and we have only one letter in the alphabet, which is A. As you see, we have a lot of fonts for this A. So, how in the world can an OCR application recognize the letter A from these fonts? We have two ways to do it: pattern recognition and feature recognition. On pattern recognition, the algorithm has a database with a lot of fonts for each letter, and with what actually it tries to do is to grab each font, each letter with a specific font, and put it over the image character that want to recognize from it. So it's basically like childs that are playing with shape sorter toys. Are you following me? Is everything right? Okay. Feature recognition. This is the smartest algorithm. So in database you have features from each letter, like that two bars, and the bar in the middle, how it's going to recognize them. It's searching through the image for two bars that are coming together on the top, and one bar that unites them in the middle. So this is how a capital A character will look. So this is feature recognition is used in modern OCR algorithms. Tesseract is the library that I used for optical recognition, and let's see how it works. So basically, the first thing that tries to do is to split the text from the images into lines. So it split the lines, and then split the words from the lines, and after that split the word in characters, and then apply feature recognition on each character. Of course, tesseract does some sort of processing image before, but it's not enough. So you need to do more processing by yourself in order to get an image in the perfect shape for recognition. So let's see how we can prepare the images for OCR. We have several steps: rescaling, binarization, nose removal, rotation, and border removal. Rescaling. So tesseract works best with 300 pixel per inch images. So if you don't have an image like that, you need to rescale it to be at least 300 pixels per inch. Of course, the image is going to be smaller, but with more pixels, so the accuracy is going to be higher. The binarization. The binarization is the process that makes the pixels from the image to be only black and white. This is you need to get rid of everything that you don't want. So you want only the text in black and the white background. This is the only thing. You don't need background with a lot of noise and stuff like that. So this is why we apply the binarization. So binarization have also two steps: turn the image into grayscale and apply adaptive or global thresholding. The grayscale. So as you see, we have an image with a lot of colors. For recognition, we don't need that colors. We need only black and white. So we try to turn the image into an image with shades of gray. If you're lucky enough, you're going to have an image with 50 shades of gray. Yeah. Next one. So with thresholding, we do the actual binarization. So we turn the image into black and white. For that, we need the threshold. Let's say black. You know that black is 0, 0, 0, 0 for RGB, and white is 255. The threshold is going to iterate to each pixel from the image and compare it to the threshold. So if the value is smaller than 180, it's going to be turned that pixel into black. If it's higher, it's going to be turned into white, right? That's why we need to put it into gray, because you know, as black and white have 0, 0, 0 and 3 times 255, a gray shade will have also the same values for the RGB, right? So for example, a lighter gray will have 200 for each value. So they can compare with the threshold. Okay, this is a pretty good example, because we have only black and white here, but also the pixels from the word yellow are pretty lighter, so the value is greater for the pixels than 180, and they are going to be turned into white. So this is an issue here, right? But we have a worse example than that when we have shades. When we have shades in the image, you see those pixels from the shade are going to be less in value than 180, and they are going to be turned into black. So we lose a lot of text here. So we have a solution for that. That's adaptive thresholding. With adaptive thresholding, the image also iterates through all pixels, but apply the threshold only on a part of the image. So you need to provide, let's say we have a pixel, the adaptive thresholding takes all pixels surrounding them, makes an average, and then compared to threshold. So in this case we can work it out, right? Also here you see a line. This line is because the contrast is very high between the shade and the background. This is an artificial shade added with him. So in real life you will have a gradient between the shade and the background, right? So then you are not going to have this line here after adaptive thresholding. Any questions until now? Everything okay? Good. The next one is noise removal.
I have one question for this image. If let's say for some reason you do have a text that looks like this, how do you get rid of the line?
Of a line? Yeah, that's an interesting question. So I think you need to do a little bit more pre-processing after this step, because you see now, but you don't really need actually, because this line is not a character, so it will be not recognized as a character, right? So it's pretty much good. Or you can make some smart algorithm that can detect it as noise.
Will not interfere with the read of the yellow word, for example?
Tesseract has a specific thing that breaks the united characters. So probably we'll break this one.
So let's say that the word yellow is both in the shaded part and the non-shaded part.
It's both on this. Yeah, probably the line is going to interact with it, and you are not going to have the best result, but you have some characters before the line and after the line. So you can work it out with algorithm after that. Okay, noise removal. As you know, noise removal, the noise, there are a couple of pixels that are gray here. So we don't want them, because the algorithm is going to detect them as some characters like points or bars or stuff like that, or even UTF or 8 format. So it's pretty nasty. You need to get rid of that noise. You have two ways to do it. If you don't have that much noise, let's say that you have less noise here, you can apply a blur on the image, and that blur what does binds the pixels that are noisy with the background. So the pixels are going to disappear from the image, but for this type of image you cannot make it with blur, because they are pretty close to each other, right? There is an algorithm for this thing, but it's on Image Magic, if you heard about it. It's a library and applies of math magic that removes the noise from this one. And yeah, I don't really understand, but yeah, it does the right work, and it's written in shell. So there you can. I will leave the link in the presentation after. You can look into that algorithm or even use it if you want. Okay, the rotation. As I said before, tesseract tries to break the text into lines first, right? So it would be nice to provide an image with lines that are horizontally aligned, right? So we can do this also There is on tesseract description. There is a page on tesseract where you can see a lot of improvement from preprocessing, and there are several libraries which you can use for better recognition. I will leave the description for this one also. Border removal. As I said before, you don't need anything but text and white background. So the borders are in plus. You need to remove them because you are going to confuse the tesseract and tries to find some characters in this part.
This means also cropping, like if I
Yeah.
have just 3 lines in the middle,
Exactly.
on an A4, it
Yeah,
will
but
crop.
you don't know exactly how big is the border there if you crop. So you need to make something smart to crop it. Like, I don't know, blur the characters and unite them, and then apply a threshold, and you will have here like a cloud thing, and you can draw a rectangle around it and crop that part only. So you can make things with in this part. Tips and tricks.
One thing.
Yeah.
Can you move back 2 slides?
Sure.
Another one
Okay.
is tesseract knows how to recognize the angle of the text and automatically put it on vertical.
Yeah, it does, but I don't know if it's accurate enough. On tesseract description said for better accuracy you need to apply by your own these things. So tesseract is going to try to reorientate the text, but you don't know exactly if it's going to make it okay or not.
So this means it won't treat distortions.
Distortions.
Yeah, either by will or accidentally, like captcha recognition. They are distorted in order to confuse the algorithm.
Yeah, exactly.
Some captcha programs will try to distort the image. I presume tesseract will not do that.
Will not do that. You need
Or
to-
if it's a scan page, maybe the text got distorted because of the scan or something
Yeah,
like
but
that.
if the disorder like characters are like this, that's not a problem. The tesseract is going to recognize it. I will show you on the tips and tricks part what can you do on that part. Okay.
I have a question.
Sure.
Can you go back one slide, please?
Here.
Here, yeah. Do you apply noise removal before thresholding or after?
Yeah. If you apply it before the thresholding, you are going to have a lot of pixels that are colored and a lot of things like
But
that.
if the first image looks like that the algorithm, the noise removal was applied to the grayscale image.
Yeah.
So if you apply thresholding, you should have an image like that, only with 2 shades of gray, which is white and black.
Yeah, it's right, but I think it's going to make it even if it's a binary image. Because
It might work, but the image will not look like the first one.
yeah, right. So this is only a gray image, it's not binarized image.
And that one looks particularly like an image, a gray image, which suffered from noise removal.
Yeah,
If you look at the background, you see that are different shades of gray. So yeah, maybe
yeah, that's
try-
right. Or it's not that good resolution for the image, so it was not taken with a good camera or something like that. Yeah, you can try both. I think it's going to work after, depends. If there are united pixels here, probably are going to be transformed in black if you apply global thresholding. But you can apply adaptive thresholding on
It
this.
doesn't matter. If you apply thresholding to that type of image, you will obtain an image like that with black and white. That's it.
Exactly like that.
I don't know how. I don't know, but it will, after thresholding, you will have an image with only black and white.
Yeah, but here you are going to have black pixels.
Of course.
That's the issue.
I think it would be interesting to see how adaptive thresholding applied to the first image would, I mean, what would the output for that be compared to noise removal?
Yeah. We'll see at the demo if I can do something for this one. Other questions? Okay. So let's see. Tips and tricks. Here, as I said before, you need only the text and the background. So for the image, you need to apply something to get the text from there, only the text, to crop the text on that image. Because if you have a big part of an image that doesn't have text, tesseract is going to go through this image also. So you don't need that. You need only that part. So maybe you can do something to like distort them, and as I explained before, and try to get exactly this part from the image and then apply the OCR algorithm about it. Also, for tesseract configuration, you have a parameter called PSM, page segmentation method, and here you can tell him what do you need. So let's assume that you are kindergarten and you have you have a paper with one character in it because you are learning the alphabet, right? So you can say, okay, my image is only with a single character, or my image is only a single text line, or stuff like that. So here you can if you say, okay, it's an all image is a paragraph or something like that with a lot of text, tesseract is going to try to split it in lines. If you cannot split it in lines, then it tries to find the characters even if are doesn't align, as you said, as your question before. So the characters that are not in line can be recognized also. So these values you can use for a better accuracy. Okay. Demo time.
Just one quick question. Sure. Do I have, like, the library has a confidence level? Like, maybe I'm scanning thousands of documents and I want to know if I'm putting junk in my database or if the recognition succeeded. It's quite dangerous to maybe switch a word or the text or something like that. Do I get a signal like, okay, Vlad, from 100 words, 4 of them I don't think I did a good job and 3 of them are junk?
You don't have to tesseract, but you can do it by your own. You can, I don't know, let's say if you get a set of images and add in database the exactly text from them, and then apply tesseract on images and compare the text and the words to see a percent of accuracy. And then you need to tweak with the values for thresholding and stuff like that in order to make a better accuracy. Also, you have things like images are pretty different, so you have a lot of shades or you don't have a lot of shades. So the parameters for thresholding and all the functions are not the same for all type of images. So maybe you can make something smart to recognize the type of the image. So it's with, I don't know, go through pixels and see if it's more shaded or not, apply a thresholding, don't apply an adaptive thresholding. So there are a couple of things to do, but you need to do it by your own. So the library needs a simple image that is a binary image and is going to get you back the text.
And from your experience, what accuracy does the library have?
It depends. So it depends on your preprocessing steps. Depends very much. So I think the tesseract, if you provide it a very good image, is going to be 96% or something like that. I don't remember the number. I don't want to lie you, but it's something like that.
It's very important the light of the image, the camera, the quality of the image, and so on.
Right.
So if the image has a good
The
quality,
lights
the
on the
results
image,
will
the
be-
shades on the
yeah.
image. So you have a lot of points there.
could you apply two sets of pre-processing different and detect them both and see if the output differs and then extrapolate the score from
Yeah,
there?
you can make everything by your own. You can do a couple of pre-processing steps, multi-threaded, for example, and you have different types of pre-processing for the same image, and then get the text and compare it, which is better from this image.
How is the validation done? I mean, you decide, you analyze an image, and you decide how good is the accuracy or...
Yeah, you don't have on the track something that tells you, okay, it's everything perfect or is only 70%.
So if you're not satisfied with the results, you will do the pre-processing again and run the process one more time on the image, right?
Exactly.
Does the language play a role in character recognition success rate? Like maybe Chinese doesn't do well, but English does very well.
So Tesseract have a couple of languages that works with, so you can put it even Romanian if you want.
Yeah, but maybe you will have trouble with special characters.
Yeah, it's possible because they can recognize it as two separate characters. For example, you know that A with a comma, they can recognize it as a comma and an A, not the.
It's the same thing with Shrill and Su.
Yeah, it's the same thing, but it tries to recognize it if you put it in Romanian. I didn't try it with the Romanian language now, so I cannot tell you exactly, but you can do this. Also, you can recognize handwritten text, but not by default. You need to learn the algorithm to do that. So you need to provide it a lot of sets of data with handwritten characters, and then you can try to
some kind of machine learning.
yeah, if you want to do handwritten. Any other questions?
Yeah, so the thing is like this. At this point, there is no tool to provide everything that you need. So you need to do some tweaks, some hacks to adapt it to your needs.
Depends on what you understand by a tool. If you say an application, there are some applications.
Something like a library, and you just provide images and will return some text.
You don't have something like this. You can, for pre-processing steps, you can use opencv library, which I use today. That can do a lot of things for you, like blur thresholding and a lot of stuff that you don't need to implement them.
I think Peel also has.
Also, people have some. Or image magic scripts also that they are pretty good. But you have to also Tesseract for Python. Tesseract is only a wrapper, so you need to install the Tesseract as a processor or as an application on your computer. Or Windows, if you use Windows, the Python library Tesseract is going to make a pull open, and open a process with the Tesseract, and you can provide the command line arguments to it. So it's working because it's a C implementation, and you only call it from Python. Wrapper with all functions. Okay.
Is Tesseract powered by Google? Or was
No,
Google?
Tesseract was started in '85 by HP, then went open source, and then Google contributed to it until now. So it's an open
And
source.
are they
project.
using Tesseract on their applications for OCR, like, I don't know, Google?
I don't know.
Stealing books.
We have also some algorithms which are not Tesseract that are more good than Tesseract on recognition, but they are not open source, so you need to pay for them. This is the best open source engine for OCR. Okay. So does everyone see? It's okay. No? Okay, let's see what we can do.
also switch to presentation mode in Python.
Yeah, but I don't want to switch to presentation mode because I need to show you images and stuff like that.
Okay.
Okay. Let's apply a simple threshold on an image.
And make the font a bit bigger.
Bigger than this? Okay.
Yeah. As big as it allows it to be.
It's console font.
Which?
Yeah, console font to calculate the editor change.
I don't know.
You broke it.
Yeah, I broke it.
I just crashed.
Certeza console font da porta de jos, nunca recordo isso.
Yeah, it's console font here. Okay. So,
Magical control she scrolled on editor.
no, it doesn't work like that. I don't know exactly where it is. Does everybody know the font?
Yeah.
Okay.
Okay, now it's better.
It's okay like that? Okay. So we apply on this image first. Okay. It's going to take some seconds because I applied some cropping part. Okay, so we have that. Let's wait a little bit. Okay, so the image recognized is this one. I cropped a little bit more, I think, from the image, but yeah, we have something. So from an image like that, the binary part looks like this. And the recognition text is here. Okay, so let me scroll it a little bit. Okay, so the recognition is pretty good here, right? But this is a global thresholding and it's a clear image here, right? But let's say that we don't know exactly which image is, and we try to apply an adaptive thresholding also above it. Let's apply it and see how it works. So we'll see the difference.
You are using adaptive thresholding from opencv.
Yeah. Yeah. You see? So we have a lot of noise here. That's not good. So we need to do something about it. Here you can work. You can work with blur. So if you apply a blur here, you can get something better than this. Let's see.
Yeah, but you apply the blur before the threshold.
Yeah, this is how it works. You need to blur the image and only after that apply the threshold, because the threshold is going to make the pixels more descriptive. Yeah. So you see that the noise was removed with blur in this case. So it's pretty good. The recognition also is pretty good. There are some characters that I don't recognize. Let's see here. In mail, you see that we have that bar was translated at euro sign and codes and stuff like that. But it's a pretty small thing. So
Does TensorFlow take into account the context? Like if one letter from one word is abnormal, does it fill the letter with the correct one?
no.
anything. So
You need to do that by your own. So you get the text, and then let's say that you have a dictionary with a lot of words, and compare it, and then work it out from there. So, yeah. Okay, that's the first example. Let's take an image made by my phone. Let's take. Let's apply only thresholding to see what's happening when you have a lot of shades, shadows on the image. So I will take this image. You see here a lot of shades. Let's see what's happening after it's refreshing also. You see? That's not good at all. So you lose almost all the text from the image. Now let's apply some adaptive thresholding and some blur to see what's happening. Probably. Let's see.
you need to select the image again.
Yeah, I didn't select the image. Okay. Sorry for the delay. Okay, so we have something.
But
It's a problem there. It's a problem with those pixels because you see the pixels are lighter here, and you cannot work this out with blur. Or if you add too much blur, then the text is going to be more blur than needed. So there's not very good. But you see that the tesseract recognizes something, but it will take into account this noise also. So this is not good. You need to do another pre-processing part here to crop only this part from the image. What pre-processing part I did to crop it takes into account also that.
So what's the noise?
That is the noise.
What letters did you find there? Or, no, in the output.
In the output here.
That's all.
Oh, okay. You see the noise. I just see the noise now, right?
Okay.
Nice.
Okay, yeah. But not
Next,
good enough.
sign.
You are using all the time the same type of blur.
Yeah. Now for the demo, yeah.
Okay, because as a suggestion, there are different types of blur.
Right.
And for example, if we use Gaussian blur,
It's Gaussian blur on the presentation.
there are, I think, 2 or 3 parameters for Gaussian blur, and you can play with
You
the
can tweak with
parameters. I think there are some algorithms which select, like automatic thresholding. There are algorithms to select automatic the parameters for the Gaussian, and the parameters are obtained from the image you apply to it. So if those parameters changes, the results will be changed. So yeah.
Yeah. So you should do something smarter there to work with.
But opencv is very good at this stuff.
Yeah. Yeah, you can use it, but you need to make an algorithm that changes the values for you in order of what type of image do you have. Do we need more blur or not? Do we need stuff like that? So here maybe you can apply some blur or some stuff like that, but I don't know if it's going to work with that. No. So okay, let's apply it on another image to see. We have. Let's say this image. Okay, you see here we have a receipt that is not very good shape, so we'll see the results. Pretty good. But you see here on Pixel we have some noise and add some characters before it, so But from an image, you see now why do we need thresholding? Because here we have a lot of shades, right? So on this part we have only black and white. Good enough. So we can work it out from that text on after the OCR. You can check it with the dictionaries and stuff like that and see if it's okay for you. Also, I don't know if I have here an example to show you. Yeah, let's take this one. This one is right. You see, I will explain you this issue also. What's happening here? Those characters have a bar here. Right, so from feature recognition, that said it's an A. Because it's searched for, let's say, two parts that are rounded,
Two circles.
yeah, and then a bar between them. So this looks like pretty much an 8, right? This is an issue. We need a solution for that. I didn't thought about it until now. I said I saw it after presentation, but it is nice to see stuff like that. So. Yeah. What's happening here? Because I use Windows now, the Windows have a default encoding on CP1252. Not UTF-8, and probably the algorithm gets some characters that are in UTF-8 and tries to convert them to make it UTF-8. But because we install tesseract on Windows, try to decode them in CP1252. Which doesn't have that character, so it is going to crash. If you add the same code on Linux, it's going to work on this part. That's the main issue here. Okay.
You put it code into something just prints the garbage.
Yeah, but
That prints as garbage.
but Tesseract does this for you. So when you make a full open for Tesseract, the result is coming through console. So the console default is CP1252. So you cannot work it out for that, right? Okay. Let's go to the other demo. Okay.
Can't you use a raw stream and decode it yourself? And then you don't care what the console sends.
Yeah, I don't know what does exactly mean.
Meaning from the console, you get the characters, but you cannot decode them when you read them. But if you read it as a byte stream or as a raw stream, then you get all the information from the console type, and you can first decode it in UTF-8 and then convert it into whatever Windows wants.
Yeah, but I don't know in which format Tesseract provides that to you.
No, what I'm saying is from Python, if you try to read the data from the console as not as string, but as a raw stream.
Okay. I didn't try it. I'll try it. Maybe it's a good idea to try.
Is that the only tesseract wrapper? The one with the open thing?
That I found most used. So
there's
I
nothing.
didn't saw one.
There's nothing in process that like loads a DLL or something.
I don't know this. Maybe it is and I lie, but I don't know. Okay, so I will show you an example if it's going to work. I made an application with 3 components: an Android application, a Chrome plugin, and a server with WebSockets in Python. So it's the example with the Exchange shop here. So we try to get the data from the identity card and display it on the image. How I made on the phone. How I made the binding is with this QR code. When you open your Chrome, the process is going to be created for your plugin, and from there you send a request to WebSocket server. Hey, I'm a browser, and I have this unique code. Now, on the mobile application, you will have a QR code part, and you read the unique number and send it to the WebSocket server. And now the phone with the Chrome plugin are binded, so you can send message from one to the other. So let's try it. I don't know if it's work with this light. It's a pretty complicated example because this one reflects the light. So probably we need to try we need to try multiple times in order to work. But let's see. The connection was not made. Let me try again. Okay. Yeah, pretty good. Pretty good. So the name is correct. After Augustine, added an E, but this is pretty complicated because you have a lot of noise on your identity cards. You have lines like that above the character, so it's pretty complicated to make the process part to work with this.
But so how do you split the text into each field?
By name, you need to provide a name for the field. So for your, in order to your Chrome plugin to be a generic one, to work with any fields, you need to have something like key part. So for each field, like name, you have to say name in English, nume in Român, or stuff like that, in order to find them in the DOM, right? You get an JSON with all this data.
How do you identify the fields on
the identity card? Okay, so it's not the smartest way that I do it, but as you see, it works.
Do you read the labels in front of each?
I crop the image into multiple images for each section on the identity card, but this is a relative one. So I search for the identity card, I crop the identity card, and then rescale it to a specific size, and then crop the images relative to that size. So it's a hard-coded thing, right?
So it only works for our national ID. It only works for our national ID. It won't work for
it will work.
US or something.
No, it's only for Romanian now. But also for Romanian, I saw that I had a small presentation and someone gave me an identity card, and that identity card had the text a little bit down. I was thinking that all the identity cards are the same. And they are not. Surprise. Okay. That was the demo. Okay, conclusions. as you know, I said some usages of OCR. I'm curious, what do you think you can do with OCR? Do you thought about this before? Do you have an idea? I'll say to you an idea. Let's say we can make an application that reads from receives the data, right? So you can use it to make charts, like how much milk did you drink last month.
No, so you can use it on a spendings app or something like that, or cash flow app.
Yeah. So you can do a lot of stuff.
It's gonna be tricky with the long.
Then you need to do some panoramic stuff.
Yeah.
But that's a new part.
Or just stop spending so much.
Yeah. Exactly. That's the second version. So.
Asks for smaller receipts.
Yeah. That would be good. Okay. So these are the resources, and also my GitHub, so you can find the code that I showed you here. For the first example, for the second one, I didn't put it now, but I will put it next day. So you can look on that for the code that I wrote. Okay, thank you. If you have any questions or if you want to contact me, there's the email.